Thanks for the intro, Barry. And yeah, this is quite a nice one for me because it's a bit of a different one to what I'm normally presenting, which mainly focuses on invasive plants. So it's quite a nice change. But basically, what I'm hoping to discuss today is how the principles that we apply to the management of invasive plants, so things, model systems like Japanese knotweed and some of the other invasive plants that we've been looking at over the last 6 months, these can be applied to the management of other amenity sector weeds, and understanding the biology and ecology of these species is really helpful for us to do more with less. So Bo gave me a bit of an introduction, but my business, Advanced Invasives, in short, solves invasive plant problems. So today we'll be having a little bit of a look at some of the research and testing work that we've done, but unfortunately there's not a great deal of information around field horsetail and ground alder at present. Taking a look at how we can develop strategies by understanding the biology and ecology of the system, and also some of the CPD and public guidance work that we're undertaking on an ongoing basis. Brief recap about what Advanced Invasives is. In short, it's the consulting part of the business. Our R&D offer, AI Lab, is based down at the main field trial site in Taffs Well, and this all comes from the PhD field trial research that I conducted with Swansea University and Complete Weed Control. And quite uniquely in this sector and also in the ecological sector, what we recommend to our clients is broadly evidence-based, and where it isn't, it's where we can adjust our understanding to reflect, as I said, the biology and ecology of systems to get better results. So this is really what it's about, and this is a kind of scientific way of saying that what we've really got to think about is the plant target as and when we find it, and it's not necessarily directly related to invasive plants. It can be applied to the common weeds that we find out and about while we're undertaking our work. So thinking about the presentations to date this year, we've looked at rhizome-forming species, annuals, biennials, and shrubs, and we've also looked at how they reproduce, again, a target, and how energy resources are moved around these plants in order that we can better target herbicide application to minimize the amount of herbicide, to minimize costs, and also the carbon dioxide emissions entailed in that life cycle. So field horsetail and ground elder are two species that I've been finding a lot down at the field trial site following successful control of Japanese knotweed. And similar to Japanese knotweed, they're both rhizome-forming species. They're quite particularly equisetum. It's quite primitive plant, and it's part of quite a wide range of different horsetail species that are found across the UK. And what we're going to try and do is look at these rhizome-forming species and identify weak points to improve their management and to get better results for our clients. So in terms of field horsetail, it's got a circumpolar distribution, and what that means is it's found in north temperate climates worldwide. So it's present throughout Europe, Asia, and North America. And I think what's interesting with species like horsetail is that it's been imported into Australasia, and it's invasive in New Zealand. And this is one of the things that can often be overlooked. And when you think about, the plants that we've got growing in our native species growing in the UK, that these, when they don't have their herbivores, pathogens impacting on their populations, and they're released into new environments, these can be in themselves highly invasive. It's often said with field horsetail that it's the dinosaur plant, and it is very, very old. This family is a very old group of species, and they estimate that it's around 150 million years old, which is a considerable length of time that it's been successfully reproducing and spreading in the environment. Interestingly, with horsetails, they've not got lignin tissues to the extent that higher vascular plants have got, so most of the species that we see today. And instead, they've got silica to support their cell walls and also confer some resistance to grazing. And just to note, mare's tail is Herpuris, not equisetum. And although they do look very similar, perhaps from a life cycle or a plant trait-based evaluation of control methods, they're not the same thing. So coming back to the growth, I've addressed these slides in the same way that I've done with the invasive plants. So they're perennial species, equisetum, and in particular, field horsetail can grow up to around 0.8 meters tall, so they're quite sizable plants. In terms of how they grow, brown fertile stems appear before the green vegetative stems. So they appear from around March, April, and the cones are held on brown stems. In terms of the vegetative stems, those replace the brown stems. They're deciduous, so they grow and die within the same growing season. And there's small green tooth-like leaves, which, as we'll come back to in terms of the control and management, don't lend these to management using herbicides. And similarly to ground elder and knotweed, we've got this extensive creeping rhizome system, which is likely to form a large part of the plant biomass. So to give you a bit of an idea of what the brown stems look like early in the season, you can see these at left, and you can see them growing alongside some vegetative stems that are beginning to emerge at the right. And that jointed growth pattern, you can pull the stems apart, they're almost like stickle bricks or Lego bricks. They're quite unique and distinctive, and they're useful in terms of determining plant identification. A couple of months on, you can see how quickly the green vegetative parts of the plant develop, and these in particular, these tissues are now photosynthetic. So the reproductive structures are brown because they don't contain a great deal of chlorophyll, and they're not designed to be processing light energy and turning that into nutrients. These green parts of the plant, these are focused on capturing light energy. And these are the parts of the plant which are going to shade out native plant species growing in close proximity. Just to draw your attention to how the leaves, the needle-like leaves, unfurl during the growing season. You can see at left they're quite compact initially, and these then spread out later in the growing season. And at present, it's later in the growing season that it's recommended that many of the herbicides are applied. So in terms of the spread and dispersal of field horsetail, it's currently believed that reproduction is primarily vegetative. So similarly to knotweed, you've got this expansion of below ground rhizome, so it's clonal vegetative spread, and you've also got plant fragmentation. And again, in the literature, there's a focus on rhizomes and tubers. So tubers are another type of storage organ. Above ground parts of the plant, unlike knotweed, don't appear to be vectors or modes of dispersal of the horsetail plant. What does differ from knotweed, certainly in the UK, is that it produces a lot of spores or seed. And just to kind of give an idea of just how much this produces, you're looking at around 100,000 wind-borne spores per cone. So each of those little brown stems is producing hundreds of thousands of wind-borne spores, which establish rapidly and quickly become rhizome-forming, accumulating energy above and below ground. I think it's worth pointing out that some of the literature says that the spores aren't particularly good at establishing, but if you think that each of those cones is producing around 100,000, even 1 or 2% of those establishing successfully still represents a lot of plants. Just to kind of give you an idea of the scale of spread, there have been infestations estimated to occupy up to a hectare in 1 year. So the kind of rate of spread, not only by below ground extension, but also by setting of spores, is really extensive. In terms of the spread and dispersal, you've got this extensive below ground growth, creeping rhizomes bearing a lot of tubers, so swollen parts of the rhizome which accumulate carbohydrate energy. I think importantly, from a control and management perspective, the rhizomes are a dark brown black color and 3 to 5 millimeters in diameter. Now, that's a lot smaller than what we commonly encounter during excavations of Japanese knotweed. So they're quite difficult to see in the soil profile. In terms of rhizome depth, commonly you're looking at around 1 to 2 meters, but upwards of 6 meters has been reported. And just to focus on that, often you see horsetail growing in gravelly, sandy locations, but it's worth bearing in mind it's only able to persist there because the rhizome is going down certainly to a depth where it can exploit water, if not the water table. Again, similarly to knotweed, you're looking at a lot of the biomass being accumulated in the first metre to 50 centimetres of the soil profile, but it is worth noting that the tubers are forming below 50 centimetres. And just to kind of give you an idea of how many we're looking at, it's 300 to 1,000 tubers per metre cubed. So removing all of that below ground biomass is always going to be challenging. In terms of lateral rhizome extension, this is topic of hot debate around Japanese knotweed at the moment, but field horsetail has been reported to extend the rhizomes to extend up to 100 meters away from the above ground growth. So it's pretty extensive in terms of the way that the root system will grow, develop and accumulate energy. Just to give you an idea of what these structures look like below ground, you can see the complex knotted mass of the rhizome at left. And you can see some of the adventitious roots at right growing below the soil. And these particular examples are taken from some pot studies, but when you excavate out on site, it's a tangled mass, and it's very difficult to discriminate between soil and fragments of the rhizome system. To give you a bit of an idea of how extensive field horsetail is in the UK, you can see this mapped at left. Just to kind of highlight some of the other species that are present in the UK and can be often misidentified with field horsetail. Of that list that I showed you at the outset, there's a lot of these species who've got very restricted distributions. They're quite rare, whereas others, such as the greater horsetail, are much more extensive in their distribution. But just to bring it back, field horsetail is by far the most abundant in the UK, and this is what most of the management methods and remediation operations have been geared towards. So in terms of the impacts of field horsetail, and this is worth bearing in mind with a lot of these invasive native weeds, is that it's more the conditions that these plants are growing in, which are the result of often human activities, that are creating the situation that allows these plants to grow to the extent that they are, and then subsequently have impacts on native flora. So in particular with field horsetail, poor drainage or waterlogging of the ground is often the cause of the horsetail expanding its distribution, forming a monoculture and excluding other plants. So it's a bit different in terms of the way that it interacts with the UK environment. As an agricultural weed, field horsetail can clog harvesting and threshing equipment, and when it's bound up as hay bales and concentrated effectively in the baled hay, it can be toxic to horses and other livestock. It's worth bearing in mind, and this is some of the work that I've been doing this year, that the growth can penetrate tarmac, and we've seen up to 120 mil of blacktop penetrated by rhizome growth, and some of the geotextiles can be again penetrated by horsetail growth, but it's not as lignified, it's not as woody as Japanese knotweed, and the damage consequently is a lot less. In terms of the control costs, there's no data available for a lot of these species, and that is an issue in terms of the way that we address these from an amenity perspective. So looking at the current practice for field horsetail, it's a little bit tricky to be clear on exactly where the best evidence is available. It's clearly causing problems at the UK level, particularly in the amenity sector. And just talking to a lot of people as I've been out and about undertaking work on this particular species, there's a lot of anecdotal references to certain products working, certain methods working, but there's a very, very limited evidence base with respect to field horsetail and with respect to ground elders. So just to kind of recap on where we are with this species, Cultural preventative measures, so physical methods such as pulling, cutting, with compost and burning are recommended, particularly in the organic sector, but they often go back to they don't work. And if you think about the knotweed as a system, that's absolutely borne out in the research that we conducted into Japanese knotweed. Also with covering, just covering as a control method as opposed to, you know, encapsulation and things like that, it's not going to manage that below ground system that contains a lot of energy, and it's going to lie in a dormant state until it's exposed again. Tillage is recommended for field horsetail, but I mean, this is only going to be suitable in agriculture, in the highly managed systems that you find there. And one of the things that's been coming up this year is that because field horsetail is a rhizome-forming species, that we should be remediating it in a similar way to Japanese knotweed. Now, aside from the legislation, it's not really a practical way of dealing with horsetail because you've got this high seed spore production, perhaps on another property's boundary or the other side of another property boundary, and that's going to contaminate or reinvade from those locations. And I think with Japanese knotweed, it can be a viable process to screen the soil, but the large volume of dark roots and rhizome that are going to be excavated with field horsetail make these kind of processes unviable. In terms of chemical control with field horsetail, there's a range of different plant protection products recommended that include glyphosate and also synthetic auxins. Now, from what we've seen, the residual products appear ineffective at present based on our own work, although Tordon, which is now deregulated, may have been effective. And most of the application methods rely on foliar spray. In terms of integrating these systems, one of the key ones is bruising the stems prior to glyphosate application late in the season. But again, this is proposed as a method to improve the efficacy of treatment, but there's very little in the way of data to demonstrate that there's measurable outputs with that. Just a note with all of this, that all of the control methods must be applied for multiple growing seasons to achieve long-term control. And really, particularly when we're using, using cultural or chemical methods, given the size of the rhizomes, given the depth of the rhizomes, complete eradication of horsetails under most situations is going to be nigh on impossible. So in terms of where we're up to with our understanding of field horsetail, there's, as you can see here, glyphosate and synthetic auxin-based treatments. Now these are what I've found in the literature, principally in agricultural settings. And you can see you've got the 2,4-D, the N2PA, which is phenoxycarboxylic acids, and then your triclopyr, which again is synthetic auxin, and your pyridine carboxylic acid. But the point of showing you this table is there's very little about the application rates, how long you're likely to be treating field horsetail, particularly in non-agricultural settings, because you don't have the impact of tillage on the below ground growth. And at present, it's a really interesting system from a study perspective, but also because it's being increasingly realized as a problem, particularly on development sites. So moving on to the second of the species that we're covering today, we're going to take a look at ground elder. And aside from the rhizome-forming growth pattern that this species also follows, there's some other interesting things around growth, development, and also the overall structure of the plant that make consideration of plant leaf form, i.e. plant traits, really important to improve management of this plant. So looking at the biology and ecology, again, it's found across the UK and Ireland. And this one is actually native to temperate continental Europe. But because it was introduced by the Romans as a medicinal plant, and that's also why it's known as goutweed, it was introduced prior to 1500 BC. So effectively, or 1500 years ago. So this is termed an alien plant, but it's not thought of as being an invasive plant, and it's quite tricky in the way that alien plants, invasive plants are put into boxes by scientists. In terms of the introduction date to Ireland, this isn't clear, but it's certainly since the Romans initially introduced it. And just thinking more from a global perspective, ground elder is now invasive in North America and also New Zealand. So these plants with a habit of getting around, becoming invasive, even in what is termed a native setting, once they escape that, they can become problematic. Again, we're looking at a perennial, which is relatively tall, up to 1 meter in height. You've got hollow hairy stems that are green with grooves and often red blotches. And you've got these leaves that are broad toothed and arranged in threes, so ternate. So they look quite similar to elder, the tree, which is why they've got this common name of ground elder. In terms of the growth of established plants, we're again looking at an early starter, so January through to March. And again, this reflects or is very similar to what you see with the Japanese knotweed. It's able to occupy space very early in the growing season, which subsequently excludes a lot of the native plant species. In terms of flowering, quite similar to knotweed, you're looking at May to July, and you've got these big umbels, which are similar to what you get with the giant hogweed. It's in the same family, and these are several centimeters across rather than the much larger flower heads of the hogweed. But you've again got these numerous white flowers, and they're insect pollinated. And linking all of this together again is this extensive below ground rhizome. So just to give you an idea of what this looks like in situ, you can see it flowering here in Ukraine at left. You've got the stems up in the top right with, you can see the hispid spines, so these quite hollow looking white spines that you can see sticking out from the stem, the red blotches, but the overall green coloration. And down in the bottom right, you can see this ternate or three-pronged leaf structure, which has superficial resemblance to elder. Through the growing season, then you get the flower structures forming and going over to seed. You can see in the left image and also the top left image with the ants, insect pollination is key for these species. And you can see as the flowers form at the top right and then go into the seed at the bottom left, you know, it's well adapted to the UK environment. And then once the flowers are cleared, you've got a window of application there for glyphosate that you can see down in the bottom right. So in terms of spread and dispersal, there's not much information on this. There's a lot of speculation about how these plants are spread, but from what I can gather from the key sources that I've found, reproduction is primarily vegetative. So you've got, again, expansion of a below ground rhizome up to 5 meters per year, and plant fragmentation. In this case, just parts of the rhizome can form new plants. And I think from what I can tell, a lot of the movement has been people moving this plant around, initially as a medicinal plant and latterly as a horticultural species. Again, it's unclear how deep the rhizomes grow. Most of the rhizome is found in the top 5 centimeters of the soil, but it wouldn't be surprising if it extended more than a meter below ground. In terms of the sexual reproduction via seed, it's stated as important, but apparently there's limitations with the way that seeds can be dispersed in the environment. Seed bank persistence, you're looking at maybe a 1 or 2 year seed bank, and seedling recruitment. And what that means is the success of seeds growing, developing to a fully grown mature plant. But regardless of this, and this comes back to what we've found with the knotweed, colonization is rapid. So regardless of the mode of dispersal, we're looking at a plant that can establish quickly, particularly in disturbed conditions. To give you an idea again of what it looks like below ground, there's some images of the rhizome with these nodes where the above ground growth is forming from. And just thinking about how we've managed knotweed in the past, you know, knocking out all of those rhizome growing points with even effective herbicides is going to be a long-term challenging process. So in terms of ground elder, it's in the Apiaceae, so that's the carrot family, and it's a long-term introduction to the UK, and by many people it's viewed as a native. In contrast with giant hogweed, which is also in the Apiaceae, and this is reflected in the frequency of introduction. You can see, based on the red spots, that the redder spots, that many of the records of giant hogweed have been much more recent. But just to kind of highlight something as well, ground elder would have been brought in by a handful of Romans over a really long period of time, subsequently spread around, possibly by monasteries as a medicinal herb over thousands of years effectively. Giant hogweeds found this distribution in the course of 200 years, and it's this speed of introduction. It's a similar thing with climate change. It's not just the change in itself, it's the speed and the relative magnitude of that change. And that's the important thing, and what discriminates ostensibly native species from the more recent neophyte invasive plants. In terms of the ecological impact, again, disturbance, the underlying conditions of the site lend themselves to proliferation, to growth of this plant. However, once it's established, ground elder forms a dense ground cover similarly to knotweed. It might not be as tall, but it's a dense cover which excludes other native plants and slows the establishment of shrubs and trees. In terms of the socioeconomics of it, it's an agricultural weed, particularly in continental Europe. I didn't find any reference to that in the UK. And it's definitely an amenity and horticultural weed across the UK and Ireland. So again, coming to the current practice, pulling, cutting with subsequent composting and burning is not advised, although there are a number of sites that are saying that that would be a useful way of managing it. Covering, again, if it's anything like Japanese knotweed, is going to stimulate proliferation, growth from under the covering and away from the control treatment. Tillage, again, is only going to be suitable for agriculture. There's not a great deal of opportunities for us to use that in the amenity sector. And again, some of the remediation methods, so anything involving excavation, bunding, encapsulation, it's a bit of overkill for ground elder. You're not going to get this penetrating established foundations. Coming back to the chemical control, plant protection products are mainly focused on glyphosate, and I didn't find any recommendations around the use of other herbicides. We'll come back to that in a moment. But again, we're looking at this rhizome system, and it's extensive. It's likely to store a lot of energy below ground. And what we're really looking at in most of these situations is long-term control as opposed to eradication. And working with the biology of the plant and also the environment, we can do more with less. So ultimately, this is what it's about. It's targeting life history events. So when you think about Himalayan balsam, we target the seed bank. So knocking out that seed bank as far as possible allows us to focus on those few individuals that get through to maturity, and it allows us to focus our attention and money effectively to potentially deliver certainly good control and management, if not potentially local eradication. Looking at the knotweed plant, we know that we're probably not going to be eradicating it, certainly with herbicides. So we focus on the life history to think about when is it drawing down the rhizome and the resources down into the rhizome, so that we can apply our glyphosate late in season and maximize our control. Additional to that are functional traits. So you've got the properties of the plant in itself, but then you've got small differences between these different rhizome-forming annual species or annual species, which allow us to be more precise in the methods that we use in order to improve our control. I think it's worth, I did present this with the invasive plants, but thinking about eradication, control and management and remediation is really important. And it's what we're able to then discuss with our client and make sure that we're able to deliver what they need. And for the most part, I think eradication of rhizome-forming species is a very, very difficult challenge. And control and management is often what our client needs. And if we can explain what the relative merits of that is or are, we're able to manage their expectations better. And often when people say they want something eradicating, what they actually mean is they would like it brought under control and management so that they don't have to worry about it too much. I think eradication has an element of over-promising inbuilt in it. In terms of what we can deliver more with less, and that goes for the herbicide, the money, and also the carbon dioxide emissions and herbicide that we invest in our control and management operations. So to summarize the similarities and differences between these plants, we can look through them here. We've got a rhizome-forming perennial plant. It's got extensive below-ground growth, significant spore or seed production. Physical control is ineffective, particularly things like cutting, and remediation methods that would be targeted to something like Japanese knotweed are expensive and probably unnecessary. Additionally, we've got few registered herbicides tested for the ground elder, and for the field horsetail, there's few registered herbicides effective or tested. It's a bit conjectural. We're not quite sure where things are up to with that. The key differences between these plants, though, are the leaf form, so narrow glossy leaves versus broad leaves, and field horsetail is a competitive subdominant, whereas ground elder is a dominant in a similar way to Japanese knotweed. So those are the key differences that we've got a high target in order to better affect control of these plants. And coming back to this, we can do more with less, and that's what it's all about, is right treatments at the right time, thinking about what we're targeting to do more with less, and that is what it's all about. So looking at competitive subdominant field horsetail. So what we're aiming to do with this plant is we're unlikely to be able to eradicate it using herbicides. So what we're looking at is long-term growth suppression. Now, the best way that we can manage its growth is to, and this is within an integrated weed management framework, is to control the environmental conditions to reduce habitat suitability from the outset. So if there's ways that we can route paths, for example, or minimize the areas that we're going to be managing using herbicides by altering the site conditions from the outset, that's a win for everybody. There's also ways to optimize management. So avoid physical control treatments from the outset. They're not going to work. You're not going to deplete that rhizome below ground. But there's also, through active management, you can reduce the competitive advantage of horsetail by using selective herbicides. Remember, we're not aiming for eradication. We're aiming for suppression of above ground growth. And by suppressing that above ground growth, we allow grasses to establish and begin to compete with the field horsetail. Additional to that is the grasses have got a high water demand, so you're also altering the underlying site conditions. So in doing so, you're manipulating the environment to reduce the impact of the species on native plants. In addition to that, through passive management, we can think about how we reseed areas. So once we've got good control of the field horsetail, can we seed using competitive mixes? We're looking at this with knotweed in order to enhance competition and reduce the herbicide load over the treatment life cycle, because we're probably going to be going back there for at least 3 years for anything over a few hundred square meters of horsetail. In terms of the products, selective herbicides, and thinking back to the table that I presented, selective herbicides have been shown to be highly effective for field horsetail management, but they can't be used near water, which is a key drawback. Products like triclopyr that's present in the ICAID, it isn't actually on label for ICAID, but these are the ones that we should be targeting to improve management of horsetail in situ. Just kind of get into some of the discussions that I had around glyphosate. Glyphosate is proposed as being effective for horsetail treatment, but it can be quite variable. Bruising prior to application came across as one of the methods that you can use to improve field horsetail management. But of course, when you're managing it over several hectares, that's going to add a significant cost component. So wherever possible, think about using your synthetic auxin herbicides, but obviously there's going to be site constraints that you simply can't avoid. In terms of ground elder treatment, we're much more focused on an approach that we would use towards Japanese knotweed. So it's all about getting the plant down to as close to 0% coverage as possible, and then reseeding or improving environmental conditions once you've got rid of that above ground cover. So the aim is long-term control and management. And we can reduce in certain settings the control time frame by adjusting environmental conditions. But really, when you think back to how this plant is spread, i.e. vegetative propagation, really we've just got to make sure as far as possible that we're following clean working practices so that the problems that we do have don't get worse. In terms of optimizing management to reduce site time, herbicide inputs and your carbon emissions, again, avoid physical control treatments from the outset. You're not going to be improving management. You're bringing the ground elder under full control using glyphosate-based herbicides. So you've got an active management process that's focusing on timing and understanding the biology of the plant. But once you've got rid of ground elder as close as to possible, you're thinking about enhancing competition to suppress the ground elder over the longer term. So again, it's about this long-term thinking of seed mixes that may be able to exclude ground elder within that setting. In terms of the products, you're looking at a similar application and a similar thought process as to what goes into Japanese knotweed. So late in the growing season, the ground elder is drawing down metabolites, so resources into the rhizome system, and that's when you should be targeting your glyphosate applications, so from flowering point onwards. Again, similarly to knotweed, it's a broadleaf species, and selective herbicides are unlikely to be effective, certainly when we're thinking about long-term control and management as opposed to periodic suppression. The other important thing when you're using either of glyphosate for either of these species is using water conditioners, because this is one of the things that often when I'm discussing this with ecologists, we didn't get good results. It's just overlooked frequently, and really if you're in a hard water area, you should be considering adjusting pH in order to mop up the salts before they bind with the glyphosate molecule in order to improve your control results. And when you think about control and management operations, the biggest component of that is your labor. Optimizing each of your applications to make sure you do more with less is the best way of doing things from your own perspective and also from the clients. Finally, in terms of the plant functional traits, it's the key difference between these species. Leaf shape of field horsetail is really unsuited to herbicide applications. So the narrow leaves mean you've got less surface area for herbicide interception, and the herbicide that is intercepted isn't well taken up by the glossy leaves. So retention on that surface is really poor. So it's really important, I think, in particular with field horsetail, that we're using suitable adjuvants, whether you're using synthetic auxins or glyphosate-based herbicides. But just to know, always read the product label instructions, and that applies to herbicide products and also spray adjuvants such as surfactants. In terms of ground elder, the broad leaves make it quite suited to application of glyphosate late in season. But the later you go in the season, the more likely your application is going to be compromised by rainfall, and improve absorption by including an adjuvant to improve that rain fastness. Make every application count. So in terms of the summary for all of this, and I've got a nice picture of some Japanese knotweed, field horsetail and ground elder at the side of the River Taff earlier this year. Use the right tools for the job. Think about which treatments will work best using the least herbicide and labour, and minimising the use of physical methods for rhizome-forming species over the treatment life cycle is just a massive win. In terms of integrated weed management approaches, think about ways that environmental conditions can be adjusted to minimise native invasive weed growth in the first place, and then only use the treatments if you're unable to do that. And thinking long term, minimise herbicide use and CO2 emissions by using ecological knowledge to suppress native weeds growth where possible, without getting involved with using multiple herbicide products and physical methods that are unlikely to achieve your overall aim. And I think importantly, and similarly to Japanese knotweed, improve foliar glyphosate efficacy using water conditioners, and you should be using adjuvants to improve uptake, retention and absorption of all herbicides, particularly where these plant leaf traits, leaf forms, are likely to reduce herbicide interception and retention. I'm happy to take questions.
Thank you, Dan. That was very, very good. Right, let me just flip these screens over. We've got a few questions in, so we'll go through them and we'll see how we do in terms of time. Okay, so let's see here. Right, first up, Richard Wheatcroft. What is the evidence for toxicity even of grazing animals, especially after baling? Does it become more potent when dead, like ragwort?
In short, I don't know, but from what I did read, it's the baling process. The reason that it's becoming toxic, apparently, when it's eaten sporadically in a field, that isn't toxic to the livestock. It's when it's been baled and processed, it's then condensed. I would imagine because I'm not a farmer. I would imagine because it's been condensed in the hay, and the density per unit mouthful is greater. So I'm assuming that's where the toxicity with this one comes from. Just to know, a lot of the information with both field horsetail and with ground elder, there's not a great deal of good quality information on it, and I think this is where a lot of the confusion around management of both of these plants is creeping in. Pardon the pun.
Okay. We've got two questions that sort of lead into each other. First from Ian Gower and then Sarah Phillips. I'll just merge them together. So with regards to chemical control, Ian remembers a presentation from the American inventor of stem injection. He said that in his opinion, you could stem inject horsetail. Have you got any thoughts on this? Sarah then adds, if it can be injected, is application suggested only annually?
Right, good questions. Right, start with the first. In terms of stem injection, that slide that I showed you, I think it's great horsetail, 1.5 meters tall. I've never seen that in situ. I would imagine stems are bigger and it'd be easier to stem inject that. From what I've seen in most sites, and this goes for the knotweed management as well, stem injection is really time consuming, and it doesn't necessarily, I suppose it might work better with these particular plants, but it certainly doesn't work better with the knotweed. And it's always that trade-off between how effective it is and what your likely results can be. Coming back directly to that though, bruising prior to glyphosate application in really big settings, sort of, you know, anywhere up of a hectare, people are really reluctant to get people out bruising stems prior to application. So I think, and this is kind of the key kind of angle that I'm taking with this, is that given glyphosate, and I think this should be tested, by the way, I'm not in any way saying that it shouldn't be tested, but I think it'd be ideal if we could test the efficacy, long-term efficacy of glyphosate on field horsetail, determine whether these additional physical methods improve management outcomes, or whether really, realistically, what we are talking about is suppression of the field horsetail for long enough that you get the results that you need for your client. So that's kind of a roundabout answer to both of those questions, I think. But certainly in terms of, stem injecting horsetail, I think really whether you're applying it once or twice a year, it's all about the coverage, it's all about the glyphosate uptake. And realistically, I've got my misgivings about whether horsetail has got big enough leaf surface area to really get, maybe if we broke it down into a number of different treatments to maintain the application rate over the year, so 3 at a third rate, might work. But yeah, I'm getting a lot of conflicting information from different people that I'm speaking to on this particular topic.
Okay, staying on that particular species then, Richard comes on again. Is there any difference in the success of vegetative regeneration between cut stems or chopped lifted root rhizomes? I think he's going to grow back.
I don't know. I would imagine, based on what I've done with knotweed, I just avoid physical methods wherever possible. Whenever it's anything rhizome-forming, generally it's a glyphosate application with a field horsetail. I'm tending more towards synthetic auxins. because this is the key thing with the auxins. What you're effectively doing, it's going to be almost impossible. I'm just saying based on what I'm finding out on site, getting rid of all of that rhizome, field horsetail rhizome, is going to be really difficult. It's like knotweed. If you can, unlike the knotweed though, if you can balance the ecology of it to allow the recovery of native plants to do the work for you, and you're then just spot treating the field horsetail, you've come out with the same result without the fuss, if you see what I mean. You're not stem injecting them all, you're not bruising them prior to the glyphosate application, and ultimately you're coming out with that end result that you need for your client. So that's kind of what I'm getting at with these. And you know, field horsetail is quite unique because of all the rhizome-forming, deep taproot forming species that I've looked at, field horsetail is the one that the synthetic auxins is the product that I think I would be recommending.
Staying on horsetail, it's a popular topic with the questions we've got. Al Mason asks, because this is where they find a lot of their problems, what options are there to control horsetail for hard surfaces?
Well, when I was writing up a couple of reports this year, there's a lot of products coming in and off label, and in all honesty, I'm not sure there are any without basis approved recommendation. There's a lot of products that have come in and out off label for use with a knapsack sprayer this year as well. But I think if it'd be good to have a discussion with you about this, because currently there's not a lot of good products available for management of field horsetail in quite a few settings.
Okay. Then again with the horsetail, I'll get onto some ground elder ones. They're just flying in thick and fast. From Keith Gallo, has there been any evidence or research carried out on field horsetail with regards to raising the pH as a control method, mainly with construction sites and ground stabilisation likely to hinder horsetail growth?
There's been no research. This is a good question. That's exactly it. Like managing the conditions to minimise, because field horsetail is very difficult to eradicate, I think. And if we can manipulate those conditions, pH is one that's been flagged up elsewhere, but there's been no direct research on it. But I think pH, waterlogging, adjustment of site conditions is the way to go with this one. And then moving beyond that, you've got your management using the synthetic auxins to remove that above ground biomass, not worry too much about what's going on below ground, simply because it's beyond your control to a large extent, and just getting that competitive diversity of native species, other native species up around it in order to suppress its growth in the longer term.
Okay. Right, I'm just scrolling, so I'm just trying to find the ground elder one because it's all a bit one-sided here. Where are we? Let's have a look. Okay, one from Peter Fitzsimmons. Seed or spore longevity. If there's no research carried out on longevity, but do you have any anecdotal data to support it?
I do have anecdotal data. I was a bit concerned about referencing it. I think it was one of the organic gardening websites that I found that information, and it was speculative that it was 1 or 2 years. I think I was quite careful about not putting the number in there, but it was 1 or 2 years that was proposed for that. I don't know. From the searches that I've done, it doesn't seem to be something that's well quantified, although I did find some Ukrainian and other Eastern European papers on it, but the text wasn't in English, so it was a bit difficult to decipher what exactly was going on with seed bank longevity.
Okay, thank you. One from Scott Downs, right, ground elder, we're finding them all now, Dan. For ground elder, would you recommend trimming off the flowers before pollination occurs, then applying glyphosate, thus avoiding any seed dispersal issues?
Right. There's two things with this. From a practical point of view, it's often recommended that you should notify beekeepers before applying herbicide to Japanese knotweed. And it's actually come up in a number of planning permissions that I reviewed this year. But for those of you that regularly apply herbicide to knotweeds, you'll find that that's often quite difficult and you very rarely get a reply. So just on the focus around native pollinators, I think it's worth potentially giving people a shout to see if they'll keep their bees in. But I think broadly speaking, you know, the ecotoxicity of glyphosate is quite limited. We're not talking about applying this over, it's not at the agricultural scale. So I'm reluctant to say that that's a massive impact on native pollinators. Just moving beyond that, in terms of improving management, I tend to just apply, when I'm managing Himalayan balsam, when I've managed ground elder in the past, just get your application on at flowering, and it does tend to get it before the seed goes over. I mean, really what you're aiming for, and this is kind of thinking about things over the longer term, you're going to be back there next year. So the reality is it's better to get one good application on with glyphosate late in the growing season. Assume that you're going to get some going over to seed. There's going to be some of the plant, the rhizome, that doesn't respond well to treatment, and then mop up what you're getting in the next year. And if you think you've left it a bit late and it's likely gone over to seed, just get in there a little bit earlier the following year. Like, think about this as like a 3-year management program, and you can adapt between years to optimize your site time. So if you get there a little bit late one year, get there a little bit early the following year, and just assume that you're not going to be getting it all in 1, maybe 2 years. I think that would be my approach towards it.
Cheers, Dan. Okay, going back to the toxicity, Joe Mullet's just, it's not so much a question, it's more a statement, I think, to help. Animals can't smell the ragwort, so can't avoid it when it's dried and baled. So it goes back to what you were saying earlier on. There is another message from Joe here. I'm just conscious of time. Right, excuse me, Joe, but what we'll do is have that conversation offline. It's just a really in-depth conversation, Dan, about controlling something with flowers or seeds. And I know there's been studies going on, but I don't think we have enough time for the covering that. So I'll just find one last question if I can. Right, so from Joshua Brown, would bruising the weed not increase the risk of spreading the weed via vegetative growth, breaking segments off, which are then trampled into the ground? I think this will be our last one, unfortunately, but we will cover everything else later.
Absolutely, and this is what I mean by all of these physical management methods with rhizome-forming plants. You're going to do more harm than good. Don't do it. Like, you're not improving control. I'm being careful. The tests haven't been done, but I'm assuming that the bruising effect, you know, maybe it does work, maybe stem injection does work with glyphosate. I don't have the data to hand, and I can't authoritatively say either way. But, you know, physical methods should not be used for control of rhizome-forming species outside of narrow use within agriculture, because you're more likely to do more harm than good. And you know, that goes for the knotweeds, it goes for the gunneras, it goes for the native weeds that are rhizome-forming. And yeah, I absolutely agree. You're more likely to do more harm than good.
Okay, right, we are bang on time. So firstly, look, I just want to thank everyone that's taken time out to register and attend this webinar. The amount of people that have been online has been fantastic. It's a really good response, and it's something that makes us enjoy what we're doing and want to continue when we get the response we get. We have got an awful lot of questions that we haven't covered off. Joe, yours is one of those, and I'll send all of these to Dan. We will video these offline after this event, and we'll post a link to them. Any that are more in depth, a bit like Joe's, Dan, I'm sure you'll be quite happy to have this conversation with people to go into more detail. Dan, thank you once again. Everyone for attending, thank you once again. Hopefully, we'll be doing this again next year under better circumstances and not locked in our rooms to do it, but hopefully we will continue this. The feedback on it has been really positive, so it gives us the inspiration and drive to continue doing these, and we'll continue looking for 2021 some good topics to be able to do. Any other questions once we've finished this? By all means, please email me. You'll have our details on the email, and we'll cover those off in the video as well. Again, Dan, thank you very much for your time. Everyone, thank you for listening. Keep safe, and I'll see you all soon. Take care. Cheers. Bye-bye.